This final chapter considers packages, and in the packages chapter there are going to be two different types of packages. The first are packages that are built into R. You downloaded them when you downloaded R, they just haven't been made active yet. And the second will be contributed packages, and we'll do each of those in a separate video. So I'm going to start out by looking at something called a survival package. And this particular package is built in, and the survival package contains data sets and some routines that are useful in survival analysis. Start out with the following. If I were to type AML, you would see there's no object called AML at this point. However, if I invoke the library function and I bring in the survival package, which I'm doing right now, it will bring in the survival package, and in fact you can see there's a packages tab over here. And if you were now to go down and look, you would see that the survival package has been drawn in, and that's why there's a check mark here. So if I were to now type in AML, now that the survival package is in, you would see that there is a data frame. I'll scroll up here a little bit. And that data frame has a total of 23 rows to it, and each row represents a patient. And this happens to be a medical study, and the L here stands for leukemia. And so this particular person had 9 time units, and I assume those time units are in weeks, but we could go and we could check the data set, and we'll do that in a minute. And in this case, they had some chemotherapy that was maintained after the typical chemotherapy concluded. And this 1 and this 0, this column right here, status, that tells you whether or not they are right-censored values or whether they actually saw the leukemia come out of remission and return. So to find out a little more about this data set, one thing that you can do is the typical help AML, and it will tell you a little bit about the data set. So here's the name of the data set, survival times of patients, and it doesn't actually say. It says this is from Rupert Miller's survival analysis book, but it doesn't actually say whether the survivor or the censoring time is given in weeks or days or what. Let's assume that it's in weeks, but you just can't tell from here. You'd have to go to Rupert Miller's book to find that out. So here is the data set. I'm going to do a little tiny bit here with the data set. There is a routine that is called SurvFit that is built into the survival analysis package. And what I'm going to do is I am going to fit this to the time column in that data frame and also to the status column in that data frame. Make these as a function of X, which is our maintained or non-maintained status. And then we have to indicate that the data set is this AML data set. Now let me make sure I've got my parentheses right. They seem to be right. That's now done silently. And if you look up here, you'll see there is a list called KM here, which has 14 elements to it. So there's a lot of things that were created in KM right here. But if you want to see a summary of what is in KM, here's what you have. In that summary, you can see our call to SurvFit is given right here. And then what you get is you get two different groups, X being in the maintained or the non-maintained group. Again, the maintained group get the chemotherapy for a little bit longer than the non-maintained group. And here you see the time values where a remission ends. Here is the number at risk, the number of events, the probability of survival, the standard error, lower and upper 95% confidence intervals for what is known as the Kaplan-Meier estimate. And here is the same thing for the non-maintained group. Now that's a lot of numbers, and that may not be so helpful in terms of somebody visualizing what's happening. So another thing you can do, and I'll put it down here, is you can call the plot function. And you can plot Km, and we're going to give two different line types, a 1 and a 2 for the maintained and the non-maintained group. An X label here would be appropriate, and here we'll put time, and I believe this is measured in weeks, so we will leave that in place. And the second thing we want here is a Y label. An appropriate thing here would be the survival probability, and that will give us a plot. This one's kind of scrunched in, so I'm going to give it a little more space. And there is what is known as the Kaplan-Meier product limit estimate. And this solid curve here is the maintained group, and the dashed curve here is the non-maintained group. And you can see that the maintained group seems to have a higher survival probability, and that means that their remission time lasts longer than the non-maintained group. But you could do a statistical test in R, for example, a 2-sample Kolmogorov-Smirnov test would be able to handle the difference between those two to see if it is statistically significant. If you wanted to add a legend to this picture, you could say legend, and what you could do is you could put in the data structure Km, and you could, oh, I'm sorry, that's my mistake. This should be 90 and 0.7. What I'm doing is I'm finding a nice spot, 90 on the horizontal axis and 0.7 on the vertical axis, and I'm going to put a legend up there. And in that legend, I'm going to put my labels, which are maintained, and non-maintained. And we also want to put what we want in the legend, which is our line type. And that'll be 1 and 2. And that should give us a legend. Well, it wasn't quite perfect. I should have shifted it a little bit over to the left. And let's go ahead and correct those real quickly. What I'll do is I'll just go up 2, and I will re-execute that particular command. And this time, instead of putting that legend at 90, I think I'll go back and I'll put it at 75. That should hopefully be enough room so it will fit in. It does. I could go a little bit further, but at least my labels aren't being cut off there. So there's a picture of the two Kaplan-Meier estimates along with a legend for the maintained group and for the non-maintained group, where time is measured in weeks and the horizontal axis is survival probability. Now here's another example from this survival analysis package. Let me clear out the screen here. There is a data set known as ovarian that is in the survival probability package. You can see this time we have 26 patients, and now you can see there are a number of covariates that are maintained on these. And the meaning of these covariates can be found from the help page. But here are 1, 2, 3, 4, 5, 6 different covariates that are all done, collected that is, on the ovarian data set. By the way, one of those may not be a covariate. That could be the actual survival time. So there is a routine. I'm going to fit a Cox proportional hazards model to this. And there is a Cox pH routine, and that stands for Cox proportional hazards. And in this case, if I want to take that data set and say I want the time and one of the covariates, and that's the, I'm sorry, that is one of the, that's the, I should say, this is the time at which the ovarian cancer, I believe, recurred, and this is going to be a censoring or a non-censoring covariate, and we want that to be a function of age plus Rx from the data set ovarian. This will fit the Cox proportional hazards model to the data set, and if you want a summary to see what that looks like, you can say summary Cox pH, actually Cox mod, which is the name of the target or the object that contains the information. And here is the result of that particular command. What it tells you is that the call was made exactly the way we had it keyed in. There are 26 patients and there's 12 distinct event times. Here are the Cox proportional hazards coefficients associated with age and Rx. And again, if you want to find out about age and Rx, you can just type in question mark ovarian, and over here you will see age will be the patient age in years, and Rx here is the treatment group. And down here, this is from Terry Thurneau, and you can get a reference if you want to read more about it. There's a 1979 paper that you can read about this particular data set. But in any case, the age of the patient, it turns out, if you look over here to the p-value, is statistically significant, but the treatment group, which is oftentimes what's of interest, was not statistically significant because it's got a p-value of 0.2. So there's more information in there, and you can dig into that and how the Cox pH routine works. But there are some examples of using a package which is named survival that is held within R. That is a built-in package. In the next video, we're going to look at 2 examples of contributed packages.